Hey everyone, welcome to another BTM screencast. Today we'll be looking at Chapter 37, Framing the Exterior Wall. So standard rough wall heights are usually 8 feet 0 inches. You can use pre-cut studs of 92.5 inches, and that gives you a wall of about 8 foot 1. Sometimes stud lengths must be calculated. So if we're going to calculate the stud length, we need to add the finished floor to ceiling height. So in this case, it would be our finished floor here and our finished ceiling height, the finished ceiling thickness. So let's say that this is 1/2 of an inch, and our finished floor thickness. So if we say that is 1/2 of an inch, then we know if our finished floor to ceiling height is 8 feet 0 inches. If we add the 1/2 inch and the 1/2 inch overall, we will need 8 foot 1 inches. For the height of our wall, but we have to remember to subtract 3 plate thicknesses. So we'd have to subtract 1.5 inches for the bottom plate. And then since we have a double top plate, that's 3 inches. So if we have 8 foot 1 minus 4.5 inches, that ends up giving us let me move that. That ends up giving us 92.5 inches, which is why our pre-cut studs are at 92.5 inches. Because if we work backwards, if our stud here is 92.5 inches, and we have 1.5 here, and because we have a double top plate, we have 3 inches here. Again, if we add all of these together, we have 4.5 inches for our plates, 92.5 for our studs. That ends up giving us 8 foot 1 for the entire height of our wall. And so if we were going to do a balloon frame, it's kind of the same. To find the stud length, you have to add both floors though instead of just one. So it's a little bit more complicated, but again, we won't be doing this in lab. So unless you have a specific interest in it, don't worry too much about this. If you are interested in it, it is something that we could work on. A story pole is used to determine length of studs, jack studs, trimmers, and cripple studs. So once you know what the height of your walls are, you're able to take your story pole and mark it. After you're able to mark it, you can come through and lay out. So they'll indicate the length of the studs that you need and all the other accompanying framing components. They also indicate the thickness and height of rough sills and location of headers. And a different story pole is made for each floor. So this comes in handy when you need to lay out your walls and you need to start cutting for all the different window openings and everything else that you need. And you're able to use this instead of measuring everything. So rough openings, Door and window schedule indicates rough opening sizes. So we talked about door and window schedules before, and those will determine what rough opening that you need. The rough opening for a door, it must be large enough to fit a door, the door frame, and space for shimming, but you don't want it too big so that you have a sloppy fit. Many of the doors that we use now are pre-hung doors, so you just need the rough opening for the pre-hung, the assembly, and make sure you have enough room for shimming, but not too much. And remember, the bottom member of a door frame is the sill. So here we have an example. Here we can see our jack stud. A little bit of foam sealant for insulation. Our door jamb is right here. Weather strip, so this is an exterior door. And the door threshold, which this height will change once the finished flooring gets installed, because you can see we only have the subfloor here right now. And of course you can see they use this piece of OSB as a shim. So door rough opening height and width are determined by adding different dimensions. Again, the doors that we'll do in here will be pre-hung, so we're looking for the height and the width more or less. Window rough opening sizes should be obtained from the manufacturer's catalog. Again, this will be specified on the window or door schedule for both of these. And we'll be going over that shortly. So to find the rough opening height for your door, we have to look at what the thickness of the finished floor is. Here, the space for the door sill, which is right here, and you can see that this is angled going outside. The height of the door, the thickness for the head jamb up here, and then we always leave about a ½ inch of space on the top, right below the header. So that allows us to shim and make sure that we have it in place where we want it. And then to figure out the width, generally it's just 2½ inches larger than the door width. So a 3-foot door is fairly common. So if we wanted to have a rough opening for a door of 3 foot, then it would be 3 foot 2½, or 38½ inches. Now here we can see two different jambs. One has a stop over here, and this one's rabbited in. Don't get too concerned on this. The doors that we'll be using will be pre-hung, so you don't need to worry about whether or not it's going to be rabbited or installing a door stop. So now let's talk about wall layout. Generally there are 4 types of walls. So we'll see load-bearing walls, non-load-bearing walls, load-bearing partitions, of course these are on the inside, and non-load-bearing partitions. As with everything else, each wall must be laid out, and each has a slightly different layout. So let's see what that means. So here we have a diagram, and we can see it's color-coded very nice, where we're able to see which are our load-bearing walls, which are our load-bearing partitions, which are our non-load-bearing walls, and our non-load-bearing partitions. So if we look at the construction of this, we can see on this wall that's a load-bearing wall, and this wall that's a load-bearing wall. We have our window frames, And we have our headers. Door frame, header. We have another window frame with a header, window frame and a header, window frame and a header. Now if we look at the non-load bearing wall over here, we can see that our windows don't have headers. Now, as we discussed previously, the headers help carry the weight. And that's why there'll be a 2x10 spanning the distance to help make up the difference for weight distribution. If we look at the construction of this house, you can see the way that our roof is running. It's just your typical with your common rafters, your ridge coming across. But here, our ceiling joists are running perpendicular with it. And that's where the load will be coming down on. So on this wall and on this wall. If we come over to our non-load bearing wall, you can see that this won't be carrying any weight because our last ceiling joist will be here. And then for our rafters coming up, they'll be carried here. Now because we have our ceiling joists running this way, you can see that for our interior, our partition walls, these are load bearing also. But if they run with the joists, they're non-load bearing. It's just here and here. And the partitions that we'll be doing in lab will be non-load bearing. And the exterior walls, depending on how far you get, they will be load bearing. So here we have another example of non-load bearing and load bearing. Here you can see we have the center line of our window. We have our cripple studs. Again, these end up being on 16-inch centers, even though our window is off center. And here's just some variations that you can have. Again, this is much more detailed than what we need for the class. So unless you have expressed interest in it, we won't be going over this too much. When you lay out walls, you need to snap a line on the subfloor to locate them. Cut plates to length and set in place. Plate butt seam should land on a stud, and we'll go over what that means in a second. And lay out partition and opening locations, and lay out stud locations. So let's take a look at what this means. So here we have a wall that's being laid out, and this would be our bottom plate. So if we laid this out, there would be one, and then our X's. And we can see here, these two plates land on the center of the stud, so we're able to nail in both sides of the plate. Now here's an example of what it would look like when we're laying out. These are this could be our bottom plate. This will be our first top plate. And when we do that, we're able to lay them out at the same time and mirror them. And this helps us transfer our marks over. It helps reduce error because we're doing them both at the same time. So we can see by this, there's going to be a rough opening. This one will be either for a door or for a window. We're not sure because we have a stud on this side. And we have our trimmer or jack stud on that side. indicating that there will be an opening there. And again, if we measure a 1/2 inch width of rough opening in both directions, that gives us enough room to shim. And when we do that, it should be done from the center line. So we're able, from where we're going to begin our framing here, when we lay out, come up to our center line, and then measure in each direction. And this would be for our partition wall. So again, our partition walls get laid out to the center. So we start in our corner, we come out, and we know that we're going to be centered here. And the way that our wall will be constructed: stud, 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 and then our 2x4 blocking will be put in here, and then our partition wall will come in, intersect, most times a 90-degree angle, and then we're able to fasten it. So again, here's just another way that we can lay out. So we always start at a corner, come over to our center for our rough opening, and measure in both directions. Then we can measure for our king studs. And in this case, this is for a partition over here, and that's laid out to the center. So now we have our rough opening. Now we also have our partition in the same wall. And again, we can just continue the layout process. And here we have our first stud, which we have our 3/4 inch setback, 15 1/4, and then from there we lay out on 16-inch centers, and wherever our 16-inch centers land is where they land. Now we can see on this one we're laying out for a window, and our cripple studs end up still being on 16-inch centers, which are indicated here. So C is for your cripple studs, and then they're continued throughout. And even our partition wall doesn't land perfectly on a 16-inch center, but we're able to add 2 more studs and then lay out for the center of our partition wall. Pre-cut the wall frame members as needed, so you can do this when you do your layout and you use your story pole, and you're able to figure out the lengths for the jacks that you need, the location of your headers, cripple studs. Once you figure all of that out, you can assemble the frame on the deck, and make sure, as we covered before for your corners especially, that the double top plate should overlap. And in the previous example where it showed, let's say that this is a stud, make sure that your top plate and your bottom plate, any of your plates, land in the center of your stud. And then if this is your top plate, make sure that this one is lapped so we don't have this seam continued. So if you're able to get everything set up and laid out, you can make yourself up a little station where you're able to quickly cut everything. So if you had to cut, let's say 3 dozen cripples at the same height, then we're able to set this up, have your material stop set, so your measurement from here to here would be for your cripples, and then you can cut all your cripples. Same with your jack studs. And if you need any other studs cut, or you're cutting them to a custom length, you're able to do the same thing. So after you get it laid out, you're able to take your measurement, set it up just like this, and then run your stock up to the material stop, and then cut and repeat until you have all the pieces cut that you need. It saves a lot of time rather than trying to go and measure each one and cut each one individually. And then you kind of make it like an assembly line. So here we are again looking at some corners. And we can see on this one with our blocks in the center between the two. And this stud just gets put up to there. So this would be one wall. This would be a second wall. Only one needs a corner construction. And once they're together, we'll have our inside corner and our outside corner, so we're able to hang finished material to it. And over here, we have our energy efficient corner. So this uses less wood. While we use 3 studs yet, 1, 2, and 3, we eliminate all the short blocks. We don't need them. In addition, this allows us, if we put our next stud over here, we still have this cavity that we're able to get insulation into. Whereas in this one, it would be a lot more difficult once this is installed. Here's some partition construction. Again, we went over this briefly in the previous chapter. And this is just something good to look over and have as a reference. And it shows us 3 different ways that we're able to assemble our partitions. And again, this will be dependent upon what the architect or engineer has for the house. Now here's an example of assembling the wall section ahead of time. So you can see the bottom plate is laid right on the snap line on the bottom. And then when this happens and everything gets framed as down here, this entire assembly can go and then be moved vertical and tilted up. So you can see in this example, this window opening is done first. And then all of our other studs are added in as it goes. Since this is a corner and we want our corner top plates to overlap, make sure that this is recessed, the thickness of the material that you're using. If you're using 2x4, it would be 3.5. If you're using 2x6, it would be 5 3/8, 5.5. And here's another example. So here's our corner where we'd have to lap them. So you can see that this one is continuous, and then this one overlaps at the top. Because we have a short block here, this is not an energy efficient corner. Here's our partition walls coming in, and again, we have our lap joint where this top plate would intersect with here, and of course this one would butt into the bottom one. So before walls are put up, they have to be made square before anything's braced. Plywood can be used to create a strong wall section, so you don't need to worry about it. When you hang your sheathing on, it'll act almost as a brace. Let-in and cut-in bracing are also used. We went over that previously. The let-in gets notched, and the cut-in has kickers at the top and the bottom. In seismic regions, shear walls with metal strapping are built into walls. If we had more seismic activity in the area, we would be going over this, but since we do not, don't concern yourself with it too much at this point. So here we are measuring, making sure it's square. So we're taking diagonals from corner to corner. I think this drawing is a little misleading. He has his extension lines coming out, but generally you go from corner to corner. These two should be equal. If they're not, you need to figure out why. So sometimes your wall will be racked like this, and sometimes it'll be racked like that. And you need to figure out which direction it needs to go. So in this one, you can see it would have to go in this direction. And in this one, the top would have to go in that direction in order to get it squared. So here we have a let-in bracing. Again, this is one that your studs would be notched. And the length of the brace is just about the same as the wall height. So if this was 8 feet, then this brace would be approximately 8 feet. Cut-in bracing, again, we have our kicker at the top, we have our kicker at the bottom, and then these get cut in and installed. Same, they're about equal to the wall height. Now here's some metal straps that are used. Again, we will not be using them, and so don't be too concerned about it. So when you go to erect the wall sections, make sure each section is braced temporarily as it's erected. If not, it'll be really flimsy, and if it's not braced, they could move, they could rack, they could fall. And make sure all corners are plumbed and temporarily braced, and we'll see what that looks like in a second. So here we are, we have three different braces. So on this one, you can see that this going up to the corner, these are just face nailed in. There's one of your joists. Over here, we have our bracing. Of course, this is the cut-in one. And over here, we have another brace. This is face nailed in here. We put a little block on the deck, and then we're able to face nail into that. Again, when we're doing this, we're checking for plumb. So here's one way that you're able to check for level. This is a relatively small level. If I had to guess, I'd say it was a 4 foot. Try to use a 6 or an 8 when you're doing this, because what'll happen is wood's not perfect, so you may have a little deviation. And just as suggested here, you go from top to bottom. So if you had a level, instead of using a straight edge, that's one less piece that you need to worry about. And when you have less pieces to worry about, there's less that can go wrong. So when you hang a wall, even though you had it assembled on your deck, it doesn't mean that it's going to be straight. So if we're looking at our deck from the top, and we know that we have our line snapped here for our wall, that does not mean that's how your wall is going to look. The wood that we use, even though it's kiln dried, it still has the ability to move and warp and distort, so it may not be perfect. So in that case, we need to be able to straighten the wall. So here's an example of a brace that they're using. These are dangerous. I wouldn't recommend using them in lab. This will work, but if that springs up, if it pops here or anywhere else, it's not going to make for a good day. if we were to straighten this, we'd put a gauge block here, we put a gauge block here, and then we're able to run in a line and then check along that line. You can sight it, and if there's any things that stick out, you can go through and use a gauge block. So if we came out here with a 2x4 and that was 1.5 inches and that was 1.5 inches, throughout this whole run we should have close to 1.5 inches. There will be some slight deviation. If it's anything in excess that needs to get fixed, and in that case we would use a brace. They're showing a brace in the corner, but you could just as likely need a brace in the center. Because we're going by our line here, we're able to kick this to the line one way or the other. So the bottom would be taken care of. It's the top that we need to worry about. And again, our corners need to be plumbed, braced in place. So some of the exterior walls, they can be sheathed with boards, panels, fiberboard, gypsum, or rigid foam sheathing. Each house or building can be different, and that'll be determined by the engineer or the architect. Here we have an example, and this is just plywood that's being put up. So generally, you'll see more of this, the vertical panel alignment, than we will see of this. Reason being, if we use this, we need to have these blocks in here, because according to code, and we covered this in a previous screencast, if we're using 5/8 or 3/4, we need 8 penny nails. Along the edges here, they need to be on 6-inch centers. Out in the field where our studs are, they need to be on 12-inch centers. So keep that in mind. In this one, because this is an edge, we need to be on 6-inch centers, and we need to put more blocking in. Always make sure that you do have about an 1/8 inch spacing, because the wood will contract and swell depending on temperature, so you want to make sure that your joints aren't tight. If they are, it could pop. Structural insulated panels, we won't have to worry about this in this class. If it's something that you're interested in, let me know, and then we could dive a little bit deeper into it. And here's an example of what those panels look like. Estimating is an important component for exterior walls, so we'll go over some quick ways to do it. If we're going to be figuring out a building with corners, this is a good formula, and that allows us to figure out the amount of studs that we need for the building, and that includes the corners. So for example, let's say that we're going to do a building that's 10 by 10. So then we know that the perimeter of our building would be 40 feet. We would need approximately 40 studs. And again, that'll give us our studs on 16-inch centers and give us enough for our corners. The number of wall plates. Again, since we're going to have 3 of them, you take your overall length. In this case, it would be 40 feet again. Divide by 12, and that's the number of 12-foot plates that you need. We'll be doing these in class, so don't get too caught up on the details on this. We're going to be doing more throughout the marking period. And our wall sheathing, so our wall area, you divide that by 32. Reason is our wall sheathing is 4 feet by 8 feet, and that gives us 32 square feet. In conclusion, stud lengths are derived from adding 3 measurements and subtracting 1. We went over that previously. Roof opening dimensions are found by adding 5 measurements. We also went over that previously. There are 4 types of walls with slight variations in layout. Again, if you need a review, please feel free to rewind this. Each wall must be laid out, assembled, erected, and plumbed into position, and this will be something we'll be doing in lab. Wall sheathing may or may not serve as permanent bracing. Again, it depends on the type of sheathing that you're using and what's specified by the architect and the engineer. And insulated panels are an alternative building material. Again, it's not something that we'll be covering in class.